Geotechnical Engineering Part A, Soil Mechanics, Chapter 8, Seepage. Yet we can solve this equation in a simpler approach, which just reducing from 4 unknown to 2 unknown last videos. And in this video, we just want to solve this problem with just one equation. So let's see how we can approach this problem. So this is solution 3, the easiest one. So if we want to solve this problem with only one equation and one unknown, let's see how we can approach that. And that's the equation of the interface of two soils. This is the interface of two soils. So that means K1 times I1 is equal to K2 times I2. And we just replace that for the interface between two soils. So that ends up to be 10 to negative 5, which is K1, and 2.5, 10 to negative 5, which is K2. This is K1, this is K2, and 8C, which is the head at the top here, minus HE, which is the interface head, over length of the first layer, which is 0.4 meter. HE, this is soil 1, this is soil 2. HE, beginning of soil 2, HD, the end of soil 2, over which is the length of point soil 2. If you keep a closer look, you can easily see H at C is the total head of water, because we just stand at C, and you can easily calculate H at C, which is the total amount of water, 1.2, as you can easily see in the figure, and you can also calculate that based off the equation. And H at D, you can easily see here, H at D is 0, and already calculate H at D is equal to 0 in this video. So if we just replace them, it just gives us 1.2, 1.2, let's make it a bit clean, 1.2 minus HE over 0.4 is equal to 2.5 HE over 0.3. If you rearrange this equation, it just gives you relation between HE and HE is equal to delta. It just gives you what HE is, and HE, as you can see here, H at E is this much. Based off these rectangle, HE is equal to delta H2. So if as soon as we have delta H2, we just simply subtract delta H2, which is 0.765, minus delta H1, 0.2765, just gives us what the H1 is. So delta H1 is the total minus H2, which we already calculated here, and it just gives us the same numeric value for delta H1 like previous solution. As soon as we have both H1 and H2, we can easily jot down the similar triangles. This time 35.35 over 0.4 is equal to x over delta H1. As soon as you do that, it just gives you what x is, and x is equal to 80, and if you just calculate hxx, which is 1 minus 80, 0.808, 0.8080, and it just gives you the same, almost the same, 392 hxx. So as soon as you have hxx, you can easily calculate uxx, which is hxx minus zxx times gamma w, just 0.392 minus 0.5 times gamma of in SI unit, and it just gives you gain a new value of 1.42 meters squared. And that's we already wrap it up with 3 approaches: classical approach with the equation system of 4 equations and 4 unknowns, and then we just solve it with 2 equations and 2 unknowns, and the last solution, which is solution, we just solve the problem with one equation and one unknown, get the water pressure and at any arbitrary distance between the two combination of soils. Thank you. It solved more problems in seepage.